Hello.
I am Dr. Samara King.
I am Dr. Caitlin DeRay.
I'm Dr. Charles Gladney.
I'm Dr. Austin Carnes.
And today we're going to be learning about Sir Isaac Newton's 3 laws of motion.
I wonder why it's not moving.
Katie, you're right. Wonder why.
I'll tell you why. It's because of Newton's first law of motion, the law of inertia. An object at rest tends to stay at rest, and an object in motion stays in motion unless acted upon by an outside force.
What's a force?
Force is any push or pull on an object.
Wait, so if Chucky never came to put the force in the ball will stay there forever?
Yeah.
Interesting.
An object at rest tends to stay at rest, and an object in motion stays in motion unless acted on by an outside force.
Can you demonstrate the second part of the law of inertia?
Sure, Chucky. Watch whenever I hit the ball across the floor. As you can see, the ball is going to go on forever unless another force stops the ball, just like the table and the desk did.
So in this case, there are two forces stopping the ball. Friction from the ball hitting the carpet, and gravity always pulling down on the ball.
So once again, an object that at rest tends to stay at rest, and an object in motion stays in motion unless acted upon by an outside force.
I hope this demonstration helps you understand Newton's first law of motion.
Welcome
to Newton's second law of motion.
I am Dr. Xavier Wertzel.
I am Dr. Aaron Cole.
I am Dr. Alyssa D. Simone.
I am Dr. Elijah Hart. Newton's second law of motion states that force equals mass times acceleration.
Or the acceleration of an object depends on the net force acting on the object and that object's mass.
Wait, what's acceleration?
Acceleration is the change of an object velocity over time.
Well then, what is mass?
Mass is the amount of stuff something is made from, similar to weight here on Earth, but not exactly the same.
Wow, can we just demonstrate Newton's second law of motion? That will make it easier to understand.
If I put this block, it goes far. If I put this book, it doesn't go as far because this block has less mass than this book. Since this book has more mass, it didn't go as far.
Thank you, Alyssa. What Alyssa showed us was two different masses with the same kind of force. What I'm going to show you is the same kind of mass with two different forces.
Why did Elijah's golf ball go further?
Elijah's golf ball went further because he had more mass with the putter than I did with the pencil. Does that help you understand the second law of motion?
Yeah! Okay, let's review. So the acceleration of an object is affected by its mass and the amount of force applied to that object? Yep, that's Newton's second law of motion. Thank you for watching, and here's another team of 5th grade scientists to explain the third law of motion.
Hello, and welcome to our lesson on Newton's third law of motion. I am Dr. Lexi Jones.
I am Dr. Terrell Gibbs.
I am Dr. Elijah Babish.
I am Dr. Ariana Lemon. You may have heard of this law. For every action, there is an opposite and equal reaction. In other words, when there is a force by one side, there will be an opposite and equal force by the other side, causing each side to move in opposite directions. Let us show you.
What me and Dr. Terrell just did was demonstrate Newton's third law of motion. When two objects of the same mass collide, they will go back the same difference.
The same thing would happen with two golf balls of the equal amount. They would go back the same amount, as you can see.
That's what happens when two unequal forces collide. The red ball had more mass and force, therefore there is no opposite and equal reaction.
I hope this demonstration of Newton's third law of motion helps you better understand.
To summarize, for every action there is an opposite and equal reaction.
When two things collide, they press against each other with equal force in opposite directions.
When two objects with unequal mass collide, the objects will accelerate at different rates.